Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this lesson what I'm going to do is I'm going to show you one method to solve the final chase sequence that we did, that I asked you to do as an exercise previously, the chase 3 sequence. As I say, it's only one method of doing it. There are other ways of doing it, so if you did it another way and it worked, that's perfectly fine. I'm also then going to farm it out to a function. So what I mean by that is I'm going to take the main part of the chase sequence and I'm going to put it into a function called chase and show you how to call that then from inside your main function. You're probably familiar with writing functions, but you just may not have seen it in embedded programming before, or even if you have, I'm just going to show it to you again. I'm also then going to have a look at one other a few things that we haven't covered so far. I'm going to do some more hash defines, and I'm going to show you where I'm going to use those in the program. But also I'm going to introduce the word static, which again you may have come across before, but I'm going to show you where it's particularly useful to us in this example. So to start with, I'm going to show you one method of doing the chase 3 sequence. So just to remind ourselves, for the chase 3 sequence, we have to set up the output port to all zeros. So ignore my comment there because that's from a previous program that I was writing. So all of port B set to output. Okay, so in our main function then, what we want to do is we want to try and put out the sequence where a 1 is starting on the least significant bit of port B. It progresses its way up to the most significant bit of port B and then turns around and progresses back down to the least significant and then back up to the most significant and keeps going in that order. Okay, so for this, what I'm going to do is, and again, as I said, there are a number of different ways of doing it, but what I want to occur is that within the while loop here, we make a decision each time as to what direction we're currently going. Are we going up or down? And also we make decisions as to whether we need to change direction for the next time around. So the first thing that I need to do is I need to make a variable that I'm going to store my current signal in. So I'm going to call that store. Okay, so that's where I'm going to store it. I'm going to set it to 0, 1 for the moment. Okay. Now, what I'm going to do then is I'm going to, we'll just show the main crux of it where it goes out to port B. Okay, so its current value goes out to port B, and we also do a delay. And don't forget when you're doing that delay that you must have this crystal frequency up here hash defined as a particular number, or otherwise that won't work. Okay, so that's how we would put the value of store out to the port. Now, what we also need to do then is we need to be able to shift the numbers up or down depending which way we're going. So to shift it up the way, we're going to say store is assigned store shifted by 1. Okay, and of course I can shorten that to store just by 1. Okay, that actually says the same thing. Takes the current value of store and shifts it by 1. Now, you may be wondering, why can't you just say something like port B and shift it that way as well? Well, the fact of the matter is you can do that, and that will work for you. The only issue with that is that on certain versions of the PIC microcontroller, not as it happens 16F88 that we're using in this particular example, but in certain versions that can cause spurious errors in the hardware. It's known as a read, modify, write instruction, and it can cause issues if your hardware does not have a latch on the piece of hardware, on the port pins. Now, I'm not going to say anything more than that because it's not really related to this subject, other than for you to know that it's generally something good to avoid to do that with the port pin. So you'll get away with it on this, but if you were to move it to another another version of the pick, you may run into trouble. Okay. So here's how we would shift it the other way then. We'd move it just that way. Okay, so we now have to decide how do we know which direction we're going. So we're going to have to keep some sort of a record as we go around as to what direction we're going. So what I'm going to do is I'm going to create another variable called unsigned char dir, and this is for direction. So I'm going to set it to 1 for the moment. Now the problem is setting it to 1 or setting it to 0. The trouble with that is we don't know whether 1 or 0 is up or down. Now that's up to ourselves to decide, but it's far better if I can say something like it's going up. Okay, so in order to do that, what I'm going to do is I'm going to make some hash defines up the top. And this is all to make your program more readable. Up is 1, and I don't put a semicolon on it because this is just a text substitution. Down is 0. Okay, so we're going to use those then. So we'll assume that in the first case it's going up. Okay, so if the direction is going up, I want to go in that direction. Else I want to go in the other direction. Sorry, that's the wrong type of one. There we go. Okay, so that's going to send me one direction if it's up and a different direction if it's down. Okay, that's going to go up and down. Now, the next problem that we obviously have to deal with is we have to be able to see if we've reached the end, right? Now, we don't want to do this until it comes back into the function, so I'm going to do them up here. So if store is equal to 80, in that particular case, what I want to do is I want to set the direction to down. Okay. Else, now you might just say if it's you might just put an else there, but the problem is that we have to do an else if, because we don't want it to just happen if it's not equal to 80. We only want this to happen if it's equal to 0x01. Okay. So if it's equal to 0x01, we set the direction to up. Okay. Now you might be thinking, well, the very first time it's equal to 0x01, and that's fine. That's what it'll do. It'll go in there, it'll set it to up again. But that's not a problem because we just happen to have it already set up as it stood anyway. Oh, that disappeared up. Now, so now what will happen is when we come in here, if store is equal to 0x01 as it is in the first case, that direction gets set to up. If the direction is set to up, we shift it in one direction in order to do it. And if it's set to down, it'll shift in the other direction. And then we put the thing out on the port. Okay. Now, which direction should we put this? I'm just thinking what I might do is I might just move that down to here. Actually, no, I'll leave it where it is, but the only issue with this is that on the very first go around, it won't be correct. But that's okay. It'll work from then on. Okay. Now, what's likely to happen on the first go around is that because we're equal to 0,1, we'll be set to up, and up will shift it by one place before it's ever put out on the port pin. Okay. Now, if you want that to work, absolutely, you could always put a move to a port up here, but we won't worry about it because the following time that it happens, when this shifts it into a position where it's 0, 1, that will get put out on the port, so it'll be there as 0, 1, and it's only after the delay, when it comes back around again, that it then gets shifted up and then gets shifted up one place as well. So it will be included in the run. Okay, so that's pretty much it there. Let's give it a go. Okay, so I've opened it up there, and you can see it. And all we need to check here is that it goes to the full extent each time. So it's gone to the full extent there on the most significant bit, and now it's going back. And it hits the other barrier and then starts coming up again. So that is working. As I said, on the very first execution, it'll probably miss out the first bit. You could solve that by just putting a one up here by saying, port B is assigned store and putting a delay. Okay. Now, I'm not going to leave this in the program, but this is that is how you would solve it happening the first time, just to make sure that it's done the right time. Okay, so as I said, that's only one possible way of doing it. I've seen some students doing it other ways as well, and that's perfectly fine. But this is one of the possibilities. So what I also said that I wanted to do was I wanted to show putting this into a function. So basically taking the information that's here and putting this into a function and then only calling the function from inside while. So that's the next thing that I'm going to show here, and I'm going to do that here by making a function called chase. This function doesn't return anything, and we don't need to send it anything either. So it's just going to be void chase and nothing there, and we can indeed even say void there if you like. Okay. Now, then we can write that function. We'll write the full implementation of it. So what we're going to do is we're going to firstly select the bit from inside the while loop. Let's cut that out there. Okay, and put it in there. Now, this isn't the entirety of it because we rely on the store and the direction here. Okay, so store and direction, it won't recognize those. You can even see that it's underlined them in red because it's got an issue with them. Okay, so what we've got to do is we've got to move these unsigned characters that we've created. I'm going to cut them, and we've got to put them inside the function because it doesn't recognize them out there. Now, what we could do, although I don't recommend it, is we could put them outside main altogether where they would be visible to everything. But that's a global variable, and global variables are something that we do have to use from time to time, but we try to stay away from them because it means that anybody can get access to that variable. So if you've got lots of programmers all working on the one program in different files, anybody could get access to that variable and could do something incorrect with it that you're not expecting. So we try to keep everything as compartmentalized as we can, or as modularized. So what we've done here is we've put them inside the function. And what we can then do is we can just call chase on its own like that. So the while one calls chase each time, and chase runs through its function. Now, there's a bit of a problem with this, and that's that the store and the direction, both of those, when the function is called, they are created and they're given their initial value. And when the function is ended, they disappear. In other words, they're destroyed, they're removed from memory, and their value goes with them. Now, the problem with that is that we're expecting that the next time we come into the function that we know what the value of store was last time so that we can shift it on one place, and what the value of direction was so that we know what direction we were going last time we were in the function. Now, there are other ways of as I say, there were other ways of solving this which may not have come across this problem when you put it into a function. But because we're here with this issue, I'm going to show you what you can do to solve it. Now, so firstly, just to show you that it doesn't work, let's run it. Okay. So what we can see here is that we are running it there, and we're stuck on the one being on RB1, which is, as I said, is the very first thing that happens. RB0 doesn't get used the first time because it jumps straight on, and we can see there that we're on RB1 and it's not moving. Okay, so that's clearly an issue. So we need to solve that, and that's what I'm going to do. That's what I'm going to show you now. So stop the execution there. And what I'm going to do is I'm going to use a word that you may have come across before. It's called static. Now, static, as I'm sure you're probably aware, is something that doesn't move. It's the opposite of dynamic. Okay, so it stays steady. And its use here is that when we make a static variable inside a function, it's not visible outside the function like a global variable would be, but when it's created inside the function and the function then ends, it's not destroyed, it's kept, so that next time, but while we're not inside the function, we can't access it. But once we come back, and if we call that function again, it remembers the last value that was used the last time that function was called. So even though it's a different call to the function each time, we retain some information. So it's a way of storing things inside a function that will begin and end and disappear, and when we come back to it, we can remember what we had. That's what we can use the static variable or static keyword for in this particular case. There are other uses for it as well, depending on where you use it, but in this case, that's what it's for. So what that means is that when we set it up to a value of 0, 1, and then we shift it by one place, it will actually remember next time we come round that it's shifted by that much, and it'll shift it one more, and next time we come around, it'll shift it one more. It'll also remember what the last value of direction was the last time we called it, and it will continue to update that for each running. So let's run it and see if it's working. Okay, so we can see that the one is progressing up and down. It's hitting each endpoint and coming back. Okay, so that's clearly running there. So what we looked at in this particular case is we looked at one method to do that chase3 function. That chase3 sequence. We then looked at how we could put it in a function and call that function. So remember, to do the function, you should make a function prototype up the top, so that, which is this one here, which says what it looks like. That means that we can then call the chase function from the while loop, okay, and it already recognizes it because it's seen it above, and then down below we have the actual implementation of it here. The other thing that we looked at as well was we looked at how to do some hash defines to make up and down here, which made the program look more readable and we could understand what was going on rather than using 1 and 0. And the last thing we looked at was the static keyword, which was very useful for remembering what the previous value of a variable was when we were last in that function. Okay, so we'll finish there.